This video is about decision analysis. Companies have to make decisions, and depending on the circumstances, the outcomes of the decisions will change. There are things called decision alternatives. These are different decisions that the company can make. And also there are states of nature, which is the different circumstances the company will face. Here's an example. Neil's Wheels is a company that manages bicycle renting service throughout Chester City. Since the program is gaining popularity, the company is looking to increase renting stations by 20% or by 40%. But a new dockless electric scooter renting service might come to the city, which could hurt their business. The company made a payoff table for 3 decisional alternatives: no increase in renting stations, 20% increase in renting stations, and 40% increase in renting stations. In other words, the company might decide not to increase the stations at all, or increase by 20%, or even increase by 40%. And of course, the company would like to increase if there is no competitor, but that is the states of nature that the company cannot control. States of nature is something that the company has no control over, and they have probably little idea of what's going to happen. The 2 states of nature are with competitor and without competitor. With competitor and without competitor. So here's the payoff table. The payoff table explains that if the company decides not to increase the number of bike stations, then whether it has a competitor or not, it will be still making the same amount of money, which is $5 million. Now, if the company decides to increase by 20%, then because they have to invest new money in making these new stations, if the competitor comes in, they will start lose money. And if there aren't any competitors, then because the popularity of these renting stations is increasing, it will go up to $9 million. By the way, these numbers are in millions of dollars. And if the company decides to be more aggressive and increase the rent stations by 40%, then with the appearance of competitor, then the company will be losing $1 million. Whereas if the competitor does not show up, then they are headed to making $12 million. Okay, the first question here is to draw the decision tree for Neil's Wheels. Decision tree is a graphical representation of this payoff table. By the way, this table is called the payoff table. And the decision tree, first, you want to represent the decision that the company is making. There are 3 decisions that the company can make, which is D1, and that's no increase. Or D2, increase by 20%. And then there's D3, increase by 40%. Okay, each of these decision trees, each of these decisions now will be submitted to this state of nature, and those are chance events. So for chance events, I'm going to put circles. I'm going to put 2, 3, and 4 there. There are 3 chance events for each of these. For each of these decisions, you have 1 chance event. So total, you have 3 chance events. Now for D1, you might have S1, which is with competitor, And in that case, it will be earning 5 million. So we put 5 there. And then there is S2, which is without competitor, and you still get 5 million. Now for the 20% increase scenario, if the competitor does show up, which is S1 with competitor, we'll be only making $3 million, whereas S2 without competitor will be making 9 million. For the third decision, which is to increase by 40%, with competitor, we'll be losing $1 million, whereas without competitor, it will be making $12 million. So such a graph is called a decision tree. And you want to use a square node for place where you have to make a decision, and a circle node for chance events. Now, question B, what would be the company's decision if it takes the optimistic approach? Now, faced with this payoff table, different CEOs will make different decisions depending on their decision style. Some people are optimistic, some people are conservative, and some people are they use more sophisticated approaches. So let's start with the pretty simple approaches. The optimistic approach does this. You have 5, 5, 3, 9, -1, 12 as your payoff table. This is the 2 states of nature, and you have 3 decisions. And what you look for is, you look for the best outcome. Optimistic means you look for the best outcome, which is 5, 5 is 5. Between 3 and 9, of course, making 9 million is better than making 3 million, so you put 9. And here, between -1 and 12, making 12 million is better than -1, so you put 12. Now, among these, you look at the best outcomes and say, hey, this is the best of the best. So this is your optimistic approach. So the answer is D3, increasing 40%, will be the company's decision if it takes the optimistic approach. Now, on the other hand, the conservative approach does this. You have the same payoff table, and you look at the worst case scenario. So here it's the same, so there's no worst case, it's always 5. But the worst case between 3 and 9 is only making 3 million. And here, the worst case is actually losing 1 million. So among these, the best of the worst is your conservative approach. Now, as you can see, conservative approach looks at the worst case scenario for each decision and takes the best of those numbers. Now, a little more sophisticated approach is what we call the opportunity loss table, or the regret table. And once I explain how the regret table is made, then you can understand what it means to take the minimum regret approach. Okay, so let's think about the regret table, or the opportunity loss table. Now, it's very important to know that regret means, maybe I should write that in the red. This regret means regret of your decision. You're regretting your decision. Okay. It's the reason I say this is because sometimes people get confused of this and they think regret means regret of the state of nature. But state of nature is not something that you can control, so you can't regret it. You can only regret about what you could have done, what you could control, which is the decision alternatives. So it's the regret of your decision alternatives for each of the state of nature. Okay, so let's think about this. First, let's say we are at state of nature 1. Okay, in that case, if you made the decision 1, do you have any regret? No, because that would be the best decision. If the state of nature happened to be the case and you made decision 1, then you made the good decision because that's better than the other ones. So this guy, this decision D1 has no regret, it has 0 regret. However, the person who made decision 2 will be looking at the possibility of decision 1 and say, oh, I wish I made the decision 1. Then I could have made $5 million, but now I only make $3 million because I made the worse decision than decision 1. So in that case, what's your regret? Regret will be the difference between the best decision and your current decision. So 5 minus 3 would be 2. You have $2 million of regret. Now, if you made D3 and its state of nature was 1, then your regret will be 5 minus negative 1, which will be 6. So let me write that down. This 6 is obtained by doing 5, the best outcome, minus negative 1, which is the outcome of decision 3 under the state of nature 1. Alright, now let's think about the state of nature 2. In this case, in the case of state of nature 2, what will be the regret of each? Well, it's good to always look for the best one and think about which one has no regret. See, if the state of nature is 2, S2, then 12 is the maximum profit, so D3 will have no regret. He'll be happy that he made this decision because he correctly predicted that there won't be any competitor. Okay, now then you go and look for the other ones. This decision 1 would generate $5 million of profit, but then if he looks at the possibility of 12 million, he'll have how much regret? 12 minus 5 will give you 7. So once again, let me write this down. This is really 12 minus 5. It's the difference between the best decision under that state of nature and the current decision. Okay. Now, what about the regret for decision 2? Decision 2 generates $9 million of profit, and he'll still be regretting that he should have made the D3 decision. Then he would have made $3 million more. So $3 million will be the regret. Okay. All right. Once you have these, then in the next column, what you want to do is you want to write down the max regret. So maximum possible regret for each decision. So D1, for D1, the maximum possible regret will be 7, because if he made the decision D1 under S2, he would get 7. That's bigger than 0, right? So that's the maximum regret D1 could have. D2, no matter whether the state of nature is S1 or S2, it will always have less or equal to 3 regret. Okay, so it will either have the $2 million regret or $3 million regret, so the maximum regret will be just 3. D3, you see that 6 is the maximum, so 6 is the maximum regret. Now, the minimum regret approach is the following. Whatever you do, when you look back, you don't want to be regretting too much. Think about this case when you made the decision to have no increase, and then it turned out that the competitor didn't show up in the market, and you end up losing 7 million. At that point, that 7 million regret seems like a lot of regret. So you don't want to make that regret. So if you think about that, then this minimum regret approach looks at your future self and say, if you take this minimum regret approach, you will have less regret than other scenarios. That's what this means. Okay, so here, this one is the lowest regret. So this is the minimum regret approach. And in this case, this is D2. So D2 increasing by 20% will be the result of the minimum regret approach.